Hi, boys and girls. So we are going to learn today how to multiply using models. There are two different kinds of models that we're going to use. One kind of model is called an array, and the other kind of model is called an area model. And unfortunately, there's only one lesson that shows you how to do this because it's kind of a little bit tricky, and sometimes kids get really confused about um, looking at different kinds of models. So let's take a quick peek at, we're going to look at a number, we're going to look at a model or make a model of some numbers. So let's say that we're building an array model. And you guys have probably seen these before. They are math manipulatives that are disks, and they are usually two colored disks. So we're going to go ahead and we're going to show you just a really simple array. Let's say that we wanted to show, see if I can find another one. Oops. So the music teacher, Mike, the music teacher a few years ago, would use these as ukulele picks in my class, and it used to drive me crazy because they're math manipulatives, and so some of them are kind of messed up because they were used as guitar picks instead of as math manipulatives. I guess they work really well though because they're like a pick. So let's say that I wanted to show an array of a multiplication problem. And the array that I wanted to show here, if I wanted to show how much this is worth, one way of writing this would be to say that this is 3 times 5, right? Another way that we could show it, and in the book, they tell you how to read the array one way, and then they sort of switch streams. So in this chapter, they're going to tell you that this is actually 5 times 3. I'm not sure why they're doing that because I've always learned this as 3 times 5. But they're going to say that it's 5 times 3. We're not going to quibble over that too much because it's not that big of a deal. So we're going to call it, in this chapter, we're going to call it 5 times 3. We'll go at the top and then the sides. So what they're going to show you is that you can break numbers into chunks and make it easier to multiply. So instead of multiplying 5 times 3, another way of looking at this is to say that this is 3 times 3. The red ones are showing 3 times 3. So this is the same thing as 3 times 3, right? So this red patch is 3 down and 3 across, so it's 3 times 3. This yellow patch is 2 across and 3 down, so it's 2 times 3. These are called partial products. The red is a partial product, the yellow is a partial product, and then I can add the partial products together, and that's going to give me 5 times 3, which is 15, right? We all know that that's 15. So when we take the red chunk, we know that there are 9 red squares here, right? Because 3 times 3 equals 9. And we know that there are 6, 1, 2, 3, 4, 5, 6 yellows, right? And we know that 9 plus 6 equals 15. So this model is showing us that you can break apart a number to multiply it. Now, this is kind of a silly number to break apart. I'm going to show you a more complicated number to break apart. And we're going to break it apart by place value. Let's keep our 3. Right, so we're going to keep our 3. So I'm going to have 3, 3, 3. And then I'm going to change this up so that I still have 3, but I'm going to add more to this. And I'm going to need a whole lot more chips or guitar picks. And I'm also going to zoom out a little bit so you can see the full scope of what we're doing here. So I'm going to actually move these guys over. I can throw some in here. Still need more. 5, 6, 7, 8. Correct. You guys can still see. I'm glad I zoomed out. And then I'm going to go all the way to 10. Right, let's double check and make sure that I have 10. Ooh, that's a funky one. Let's make sure that I have 10. Hello. I'm going to double check in a sec. So I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So this is a more, this makes more sense to use this, to use models when you're multiplying larger numbers, right? So I'm going to take out a piece of paper and I'm just going to write out what we're seeing here. So what I'm seeing is if we look at 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So this is showing me 13 times 3, right? So it is a model of 13 times 3. I'm breaking it up by place value. So I'm going to have this yellow chunk is showing me, this yellow chunk is showing me 10. So I have 10 yellows and I have 3 reds, right? So really what I'm seeing is this is showing me 3 times 10. That's one partial product. This is showing me 3 times 3. So if I take the yellows, I have 3 times 10. And if I do 3 times 10, I'm going to have 10, 20, 30, right? So I end up with 30. And then 1, 2, 3, 4, 5, 6, 7, 8, 9, right? And 30 plus 9 is 39, right? So when you're doing a larger multiplication problem, I don't know my 13 times tables, so this using a model can kind of help me to do that quickly and easily. You can also use the algorithm and do it like this, 13 times 3. But look at the algorithm when you're doing it. Aren't we still working with 3 times 3? Right here, here's the reds. 3 times 3 is 9, right? There's 9 of these. And then we're working with 1 times 3, but this 1 isn't worth 1, it's worth 10, right? Because it's in the tens place. So here's our 10 times 3 is the yellow. And so when we do that, we're going to end up with 30, right? And so we end up with 39. So making a model, if you're working with larger place value, making a model is super helpful. Let's do one more so that you guys can really, before I clean it all up, let's do one more. Let's do, this time we'll do 4. Actually, let's do 2 so that I have enough chips. We're going to do 2 wide. And we're going to break it up by place value again. So we're going to build an array. And let's do Let's do 4 over here. Am I going to fit? Ah, it's going to go under the computer. Okay, there we go. All right. So let's look at what the array is showing this time. So I know that if I am looking at the whole array, and I'm making sure that I have 10. So I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So I'm showing 14 times 2, right? This is a model for 14 times 2. And I want to break this 14. 14 is the same thing as 10 plus 4, right? So here's my 10, are the yellows. Here's my 4, are the reds, right? Now, if I go ahead and I break this into, if I talk about the yellows, I'm going to say this is 10 times 2. Right? That's the yellow. And if I add that to, this is 4 times 2. Again, these are called partial products. So 10 times 2, I'm going to have 10, 20, right? If I have 4 times 2, I have 1, 2, 3, 4, 5, 6, 7, 8, right? So I know that 14 times 2 equals 28, right? So basically I've broken it up by place value into 2 separate chunks. Now, one of the cool things that happens with using models is that you can multiply really big numbers and you can break them into partial products, and this makes it really easy. So for example, when you get to 5th grade, you're going to be multiplying 352 times 795. When you do that problem, you can break it into partial products by place value. So you have 300 plus 50 plus 2. Here you have 700 plus 90 plus 5. And even when you do the algorithm, when you multiply the number down here, you're breaking the number up into partial products to make it easier to multiply. Because this is a pretty big problem to multiply. When you break it into partial products, it's not that difficult of a problem to multiply. All right, so now you kind of have seen a little bit firsthand what partial products are, right? We've just taken a number and we've broken it into 2 pieces. When you get older, you can break numbers into 3 pieces, 4 pieces. Knock yourself out. You can use a lot of pieces. So we're going to look at doing some of the problems that are in our book today and looking at some of the models that are in our book today. So I'm going to go ahead and I'm going to fold my paper into 3 hamburgers because it's math, right? We always use hamburger, 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 and I'm going to go ahead and draw in the folds. My pen is still hanging in there. Barely. Come on, baby. Don't die now. Doing CPR on my pen. All right. There we go. If I double back over it, you can actually see it. It's dark enough. Okay. So if we're looking at, if we're going to start at our name in the corner, right? You're going to write your name in the corner. And we're calling this lesson 2.4. And we're going to be working on page 74 to 76. Okay? And I'm going to zoom in a little bit so you can see. I zoomed out so my chips would fit, my guitar picks would fit. Okay. So in our math book, we're looking at an array model, and they make it look just like what we were looking at with chips. So, and this is called an array. We talked a little bit about arrays. So, you can use an array to model a problem. So this says a stationery shop has 5 boxes of erasers. There are 16 erasers in each box. How many erasers are there altogether? 16 times 5. So they have colored chips just like I did. They have 5 rows down, right? Because they have 5 boxes of erasers. 1, 2, 3, 4, 5 rows down. And then each box has 16. So they broke it off right here. I must use my pen and wrote in my book. They're breaking it off right here at the tens place, right? So they're breaking it up by place value. So they have 10 here, and then they have 6 more over here. 1, 2, 3, 4, 5, 6, right? So if we look at this array, we have 5 rows with 16 dots. 16 times 5 is the total number of dots in the array. So if I look at this model, I have 6 times 5. Yellow right here, the yellow is showing 6 times 5. The blue is showing 10 times 5. And that equals 30 plus 50, and so our total is 80 erasers. Right? So this is kind of the pattern that we're going to follow, and we're going to do that. We're going to fill in the green boxes that are on the math book page, okay? So they're going to give us another problem for number 1. Number 1 says there are 4 rows of 15 dots. And you can see, if you have your math book out, you can see the picture on page 74. We have 4 dots down, and then we have 15 dots across. It's broken off at the place value, so we're starting out with 15 times 4 equals green box times 4 plus green box times 4. And that equals green box plus green box. These are our 2 partial products. And that equals green box. So if we have 15 times 4, we're breaking this guy basically in half. And we're saying this 1 right here is worth not 1, it's worth 10, right? This 5 is just worth 5. So 15 times 4 is the same as 10 times 4 plus 5 times 4. We've just broken this number into 2 smaller numbers. And we did it by place value, right? This 1 is in the tens place, so we're calling it 10. This 5 is in the ones place, so we're calling it 5. 10 times 4 is the same as 40. And if you were to look at the picture in your book and you counted all the blue dots, there would be 40 blue dots. If you counted the yellow dots, there would be 20 dots, because 5 times 4 is 20. So 40 plus 20 equals 60. So a total of 60 dots. Okay, let's do the next one. We also have a picture of an array for the next one, right? You can see, again, we've broken it off at place value. This is going to be 3 times 10. This is going to be 3 times, looks like 7, right? So we have 3 rows of 17 dots. That's the same thing as 17 times 3 equals green box times 3 plus green box times 3. And that equals green box plus green box, and that equals green box. So one of the things that's really strong about this math program is that they actually get you to show your thinking, right? And that's really important when you're working with math. Showing your thinking is really important. So in the picture, I have 10 times 3, right? If I'm looking at the blue dots, I have 3 rows of 10. So that's the same thing as 10 times 3, right? The yellow dots are showing me 7 times 3, right? I have 7 across times 3. 10 times 3 is the same thing as 30. So in other words, this is 30 blue dots. And then I'm adding 21 yellow. So the total number of dots altogether is going to be 51, right? So this model is just showing you, these are called partial products. We break a number into 2 chunks, and then we add the chunks together, right? So those are partial products. And it's that model with the dots is called, remember the word for that was array, right? Like when we're showing an organized square or a rectangle of dots, it's called an array. Now there's a second kind of model called an area model. An area model is going to show you a box that's divided into 2 chunks. Okay, so both of these kinds of models demonstrate multiplication. They're just 2 different ways of showing the exact same thing. They both show partial products. So let's look at this picture that we're seeing in our book. In a cafeteria, there are 28 tables. Each table has 6 chairs. How many chairs are there in all? 28 times 6. Look at this rectangle measuring 28 units by 6 units. 28 times 6 is the number of square units in the rectangle that has 28 times 6 is the area of the rectangle. Now look what they've done. They've broken it into smaller chunks. Here's 28 total. So the total rectangle is 28. But they're breaking it by place value. 28 is the same thing as 20 plus 8. We're still going to use 6 to multiply because 6 only has one place value. So instead of multiplying by 28, we're going to multiply by 20, then we're going to multiply by 8, and then we're going to add them together to get our answer. So 28 times 6 is the same as 8 times 6. In other words, the tan part, right? This is showing 8 times 6, which is 48. And this is 20 times 6, which is 120. We're going to add the tan plus the white, and that's going to give us 168 chairs in the cafeteria. Now, a lot of times parents get all bent out of shape about partial products, and they say, why are we making it so hard for kids to multiply? I think this is actually a really good way to multiply because it's a very visual way of multiplying. You can actually see the multiplication by looking at the model. And this is even better because you can actually count. You can count all of the dots. This area model is just showing you a representation of multiplying a big, huge number and breaking it into 2 chunks, which is actually what you do when you multiply numbers. You find partial products and add them together. So we're going to look at number 3. And number 3 looks like this. I'm actually going to draw it out so that you can see it. It's not going to be neat and pretty, but I'm going to draw the model out. And I would recommend that you draw the model too. So this is number 3. So we have one big tall rectangle, and the rectangle is 23. And it's divided right here by place value. This is going to be 20. This is going to be 3. Because 20 plus 3 is 23. This length of this side is 7. This is the same. So if we're thinking of it in terms of our green boxes, zoom in a little smidgy here. Oops, too far. So if we're thinking of it in terms of green boxes, we're multiplying 23 times 7, which is the same thing as green box times 7 plus green box times 7. I shouldn't say green box. Yeah, well, this is kind of green in your textbook, huh? And that is the same as, that equals partial product plus partial product, and that equals your final product, right? So I'm taking this box right here, which is gray or tan, and I'm going to multiply 3 times 7. Then I'm going to take the white box, and that's the same thing as 20 times 7. 7 times 3 is 21, and then 20 times 7 is 140. When I add these two together, I get 161. So we're just basically taking two chunks. We're taking a kind of difficult multiplication problem. We're breaking it into two smaller chunks, and then when we're done, we add the chunks together. And they're called partial products. That's what the chunks are called. We shouldn't really call them chunks. Okay, let's do number 4, and I'm going to do number 4 right down here. So again, I'm drawing the picture because I think with an array, it's a little harder to draw all the dots. But with an area model, it's actually helpful to draw it to see what we're doing. So we have a rectangle that's 35 long, and we're going to break it into two chunks. This chunk's going to be 30. This chunk's going to be 5, because 30 plus 5 is 35. This chunk is going to be 40, this chunk, or 4, and this chunk is 4. So we're multiplying 35 times 4. And that is the same as green box times 4 plus green box times 4, and that equals partial product plus partial product, and that equals our final product. Okay, so let's look. First chunk we're going to do is 5 times 4. We'll do this one. I think this one is the tan color, right? So we're going to do 5 times 4. Then we're going to do 30 times 4. 5 times 4 is 20. 30 times 4 is 120. When we add those together, we get 140. So in other words, you could say that this chunk's 20. This chunk is 120. When we add the two chunks together, we get the total chunkage. Does that make sense? Same thing with this one. This one was 21. This one was 140. We add them together, and we get the total chunkage. Both chunks together equal one beautiful large chunk. Okay? All right. Let's do number 1 on Let's Practice. Here we go. Number 1 on Let's Practice shows you this, and it says, write the multiplication sentence for this rectangular array and then find the product. So remember, they kind of flipped. I was telling you in the previous chapter, they were saying this is 6 times 13. Now they're saying it's 13 times 6. So we're going to write, this is 13 times 6, right? And we're breaking that into, we're going to use the exact same methods that we used before. We're going to say that equals green box times 6 plus green box times 6, and that equals partial product plus partial product equals final product. Okay, so if you want to count and you need to peek and cheat and look at the box, you can. This is showing 10 times 6, right? This is showing 3 times 6. So we have 10 times 6 and 3 times 6. In other words, we're breaking 13 into 2 chunks by place value. This one, we're kind of going like this. Boop, 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 boop. And this 1 isn't worth 1, it's worth 10. This 3 is in the ones place, so it's worth 3. 10 times 6 is 60. 3 times 6 is 18. And total them together, and it equals 78. Okay, so our product is 78. All right, now they're asking us to show 14 times 7 as an array and then find the product. Are you ready? This might take all of my ability to make dots. This is a lot of dots. So what I'm going to do is I want to show the 7 first. And I want to break this into 2 chunks. So I'm first going to show, let's see, if we want, I know we're trying to show 14 across, right? So I guess I'm going to flip it. So this is going to be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. I'm going to go down this way, 13, 14. And I have to show 7. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Come this way. Almost there. I'm trying to keep them as straight as I can because that's one of the good parts about arrays and working with those guitar picks is that you really can see if they're lined up neatly. It's easy to see them. If they're sloppy, it's really hard to tell and hard to count them. Okay, so this is showing kind of sloppily. I have 7 down, right? And so I'm going to cut it off. I'm going to cut it off 1 and 4. So right here, I'm going to start coloring them dark. I'm not doing my neatest coloring. Sorry about that. This is not, we're not calling a museum to hang up my math drawing. Oh my gosh, it's beautiful. Look at it, it's taking my breath away. Yeah, that's not happening. Okay, so here we go. So I'm showing, this is showing 7, obviously, down here, right? This is showing 10. This is showing 4. If we were to make this into an area model, this would be 14, right? So we're finding the product to that. And if we were to show that, we would say that's the same thing as 10 times 7 plus 4 times 7. And that's the same thing as 70 plus 28. And that's the same thing as 98, right? So if you were to count all of these dots, drive yourself crazy, there would be 70 here, right? Because this is 7 times 10. And there would be 28 here. And then we're just adding them together. If you were to count all of them, we drew 98 dots. This is kind of a little hybrid. It looks almost like an array and an area model together. Okay, write the multiplication sentences for this area model. I'm going to flip over and do it on the back so that I can draw it. Here we go, number 3. So I have a rectangular area model. I have a little sliver down here. This whole thing all together is 42. Sorry. This whole thing together is 42. This is going to be 40. This is going to be 2. And then the sides are each 5. And this is tan. So that's what I'm seeing in my book. So the multiplication sentence is going to be 42 times 5. Or 5 times 42. And finding the product, if we broke them into partial products, that would be the same as 40 times 5 plus, and I tend to put parentheses around things to isolate them, and you can do that to just clear your thinking and make sure that you can tell this is one chunk, this is a second chunk. And then I have 2 times 5. So that's the same thing as 200. That chunk's 40 times 5 is 200. And this chunk is going to be 10. So our total chunkage is going to be 210 when we add it together. Right? So this right here was 200 chunk. That's a big chunk. And this guy right over here is the little chunk. Little teeny chunk. It's 10. Right? And then we're multiplying, figuring out the area here, and then the area here, and then we're adding the two partial products together. Okay? We're showing 19 times 8 using an area model. Okay, that's easy. Good thing we didn't have to draw 19 times 8 with little circles. Your teacher would burst into tears. Or something. So I'm drawing an area model, and all we have to show is 19 times 8. So if this is 8, and this is 19, let's break it by place value and have this be 9, and this is going to be 10. And we'll go like this, and we'll shady. We'll make this tan. Okay? So now if we're going to write this out, I'm just going to write it below. I hope that's okay. I'm going to use another square. So I really am showing 19 times 8. And 19 times 8 is the same thing as 10 times 8 plus, remember this is a partial product, plus 9 times 8. When I multiply these together, I get 80 plus 72. And when I add them together, and 9 and 10 are really close together in value, right? And 80 and 72 are pretty close together too in value. Sometimes you'll have a big, huge chunk like this one where you have a big, huge chunk and then you have a little chunk. This one, these two chunks are pretty similar in size and scale. So I'm going to end up with 2. 0 plus 2 is 2. And 7 plus 8 is 15. So I end up with 152. This chunk is 80. This chunk is 72. We add them together and it tells us the total of the whole rectangle, right? One of the things that I've always noticed is that when kids seem to understand this pretty well in class, and then they get home, and our math worksheets used to have a whole bunch of area model pages, and kids would just freak out when they got home. It's like, oh, it made sense in class, but then it was really difficult when we were doing our homework. So hopefully I explained it well enough so that you understand we're just taking two partial products and we're adding them together. And for parents out there, that's what we do when we're multiplying. Let's say that I'm multiplying 25 times, let's do 41. This is the algorithm that we all use when we're multiplying, right? We have a partial product here and a partial product here, and we add the partial product together, and that gives us our answer. So this is what they're kind of getting the students to see and to understand. This top partial product is what you get when you multiply by 25 by 1. Because you're only multiplying, the place value is in the ones place, you're only multiplying by a small amount. When you're multiplying the second chunk, you're multiplying this, but the 4 isn't worth 4, it's worth 40, right? So you're going to put the second chunk over here. And then you add the two chunks together. This is where we're getting the kids to actually understand what this is instead of going, what am I doing? And the way to get them to understand it is to use small numbers first, so that they start to understand it with small, not double digit times double digit. It's double digit times single digit. So that they kind of start to see that numbers can be broken apart and used by place value, right? So I know a lot of times parents go, why are we doing this crazy Common Core math? It makes no sense. That's not how I learned it when I was a little kid. And it's like, well, I'm 55, and sometimes the best way to do things wasn't the way that I learned how to do things. So I find that this is a very good way to get kids to make this jump and to understand what they're doing when they do this algorithm, right? That you're really multiplying by a number that has a place value in the tens, and that's why it always ends in a 0 or a smiley face in my case. All right? So I hope that made sense to you. If it didn't make sense to you, don't worry, we'll get back to it. We'll kind of review it again, and hopefully it will make sense the second time around or the third time around. Eventually it will make sense, though, because it always does. All right. Thanks for joining me, and thanks for joining me on lesson 2.4, and have a nice day.